Okay, students, today we are going to finish off some of the work from last time by balancing some equations, and then we are going to do some moles calculations. And I hope this is all very useful, but we will start with some balancing equations, and I'm going to remind you what to do before I ask you to balance 6 or so, okay? So here we go. So I'm going to share my screen with one of these somewhere here. Okay. I hope it's coming up. Yes, there we are. So this was about balancing equations. Come on. There we are. In balancing equations, I came up with 5 kinds of equation. The first one was about reactions of acids, and that had 3 types: metal, base, which is metal oxide or hydroxide, and carbonate. And we said that the balancing equation was really quite simple if you could remember that with a metal it forms the salt and hydrogen. With a base, that's oxide or hydroxide, it forms the salt and water. With a carbonate, it forms the salt and water and carbon dioxide. Then we said that there were some other types of reaction. Sorry, we did some here, writing some equations. We'll do something similar. But there were 4 other types of reaction. The first one is called decomposition. Sometimes a question will have just one chemical to start with, and then more than one afterwards. And that means that the chemical has split up, it has broken, it has decomposed. All you have to do then is go, okay, here's an example, CaCO3. What could it turn into? CaO and CO2. Simple. Okay. The second type was combustion. With combustion, there is always oxygen. So the individual chemical breaks into its elements, all the elements separate, and they form their oxides. So for an example, here we have ethanol, an alkanol, and it contains carbon, hydrogen, and oxygen. Oxygen oxide is just oxygen. Carbon oxide, carbon dioxide, carbon 4 oxide, hydrogen, water. So the equation will show that it forms CO2 and H2O. That's it. It's that simple. So therefore, the equation looks something like this. The next type of reaction was double decomposition, where you have 2 salts and the 2 salts swap over one part of them. So, for instance, when sodium carbonate and silver nitrate get together, the nitrate and the carbonate swap partners. So we get Na2CO3 becomes Ag2CO3, and AgNO3 becomes NaNO3. Now, this isn't balanced. I said I wasn't balancing things, but today you will be writing balanced equations. The last type of reaction is direct combination. For instance, when calcium burns in oxygen, or potassium burns in chlorine, or sulfur burns in oxygen, they're all the same. They simply join. Be careful to get the product formula right. Here's iron burning in chlorine. It forms iron 3 chloride. Okay, so here's some I'd like you to have a go at. So we're going to start with you doing some equations. Here they are. And what I'm going to tell you first is this. What I want you to do is to look at these and find any which have an acid in them. If they have an acid, then you know it is the first type of equation. That's an acid plus metal or oxide or hydroxide or carbonate. Then we had double decomposition, direct combination, decomposition itself just falling to pieces, and combustion. If oxygen is on the left-hand side, it's combustion. If there are just two elements, sodium and chlorine here, that's direct combination. If there's only one chemical, that's decomposition. So look at these types of, look at these equations here, and I'll just tell you what they're going to have. So the first one is going to be an acid. Oops, why is that not writing? And a base. The second one is an acid and again a base. So this might help you know what's happening. The third one is an acid, that's HCl, and a carbonate. The third one is a double decomposition. This may help you write them. The fourth one is a direct combination or combustion. The next one is direct combination. In other words, they just join together. Sorry about my handwriting today. This one is another combustion. And the last one must be a decomposition because there's only one thing present. So write out those chemicals, have a go at writing a balanced equation for them. If you're not sure, I will go through them all afterwards. But what I'd like you to do now is just have a go at them, please. Okay, just have a go. Now, take some time. It would be really good if you can all have a go at it because it's good practice. If you're not sure, work with somebody else. But I'm going to give you 6 or 7 minutes just to do this before we move on to moles. Okay, so take a while and just have a go yourselves. Okay. If you're not sure, put something in the chat if I can help you in that sort of way. No problem at all doing that. St. Mary's, are you having a go? Yes. You can do it, I think. If you're not sure about one, just move on to the next one. Have a go at a different one. Try Ca plus O2 or MgCO3 turns into something. Just have a go because they're all equations which have come up in the examinations. If anybody wants to show me an equation and say, yes, I think I can do this, just show me. That'll be fine. I'm going to have to rename Dandora Girls because it's now just Dandora Girl. because I can only see one. Are you alone there? Is it only you? Pandora? Yeah, show me. Show me, show me. Hang on. Let me just hang on. I just need to do something with your picture. Okay, what's your name, please? Pandora? Write your name. Lavender. Cool. Nice name. Now, they are very, very good, but they are not all balanced. Okay, you've got all of the equations almost all right, but they are not balanced. You've got the right chemicals, but you need to balance them. Okay, Lavender? Good. Well, Marini, let me just hang on. I just want to pin you. Hang on. I just want to. They're very good. Well, Marini, they're very, very good, but some of the formulas are not quite right. For instance, in the very first one, yes, copper and nitric acid. Copper nitrate is Cu and then the NO3 in brackets 2. Okay, so you need to be very careful of that sort of thing to make sure you have the formula completely correct. Just another couple of minutes and I will then go through all of them. St. Mary's, hang on, let me just. A little bit further away, please. Mostly very good. The NaOH H2SO4 will not produce hydrogen. It will only produce the water as well as the salt. But that's really very good. That's a good start. Well done, St. Mary's. Good. It's not quite right, but it's nearly there. Another 2 minutes, and then I will go through them. Hello, Glory. Have you got some answers? Come on, Kabiro. Come on, Silver Spring. I know you can do this. Okay, so I'm going to start to do the equations. Okay, I'm going to start to do the equations. So here we go. So the first one was CuO plus nitric acid, HNO3. Now this is a base, and a base and an acid always makes a salt and water. So we know that water will be there. And the salt will be the copper with the nitrate. So it will be copper and nitrate, but it's not 1-to-1. Copper always has a valency of 2 under normal circumstances, and nitrate, because it's 1-to-1 with hydrogen, has a valency of 1. So it's this. Now, if you're not sure about that, this is how this works. Copper has a valency, that is the number of bonds it forms, of 2. Nitrate, and you can always tell the valency by the number of hydrogens it combines with, has a valency of 1. If I swap these two numbers over, I get it right. So Cu1, so it's going to make Cu1, I don't have to have the 1, NO3, 2. So if I need 2 of those, I have to do that. Okay, so that's how I know that it's CuNO3 2. I'll just get rid of that. Okay, let's look at this equation then. Is this now balanced? No. How do I know? Well, if you're balancing an equation, what I tell my classes to do is this. Underneath the arrow, I ask them to total the number of coppers. Guys, could you mute, please, whoever you are? Oxygens, 1, 2, 3, 4, 1 hydrogen, 1 nitrogen on this side. On this side, 2 hydrogens. That's 6 oxygens there, and a 7th, that's 7. So this is really not balanced at all. And nitrogens, there are 2 here. Now, actually, it balances very easily by doing this. As soon as I do that, I now have 2 hydrogens here, 2 nitrogens here, and 6 oxygens, 7 oxygens. So now it is balanced. Okay, very simple. Okay, so let's get rid of all of that, and we'll move on to the next equation. So the next equation was NaOH plus H2O, so yes, NaOH and H2SO4. Now this again is a base plus acid, so it'll make a salt, and water. I know what water is, H2O. The salt will be the sodium with the sulfate. Now the sodium has a valency of 1, forms 1 bond. Sulfate joins with 2 hydrogens, so it is 2. Swap over the numbers, makes it Na2SO4. So that is Na2SO4. And this balances with 2 here and 2 here. Okay. The next one is magnesium carbonate. Magnesium carbonate. Magnesium has a valency of 2 because it's in group 2, and HCl. Now this is a carbonate and an acid. They make a salt, MgCl2, and water and carbon dioxide. And rather nicely, this one is almost completely balanced already, just 2 there, and we are okay. Next one is calcium and oxygen. This is really easy. Becomes calcium oxide. There are 2 oxygens, which make it possible to have 2 of those, and therefore 2 calciums. Sodium and chlorine is very similar because it forms NaCl. 2 chlorines on the left, only 1 on the right, 2 NaCl, needing 2 NAs. CH4 plus O2, this must be burning. When it burns, it separates into carbon and hydrogen, and they form their oxides, so it'll be CO2 and H2O. I have 4 hydrogens on the left, so I need 4 on the right, so that's 2 there. This is then 1, 2, 3, 4 oxygens, so I need 2 O2. And the magnesium carbonate just falls to pieces like this. If you want, you can look back at the recording of this and slow it down and so on. But that's it for the moment. Okay, that's the equations that we have at the moment. So I'm going to stop sharing that. And we're going to move on. Let me just get it back to everybody. Right. So now we're going to do moles. Quite a lot of the centers said they would like to do something on moles. So I'm going to start quite simply with moles to remind you of how to calculate moles for a solid, for a solution, and for a gas. And I'm going to show you the way that I teach my students, and really soon they become very good at moles. If you have your own way of calculating moles, don't worry about my way, just have a go at the examples. So I'm going to give you my way for people who have real problems with moles. So here we go. So this is moles 1. Okay, so I hope this is a reminder for you and not just the first time you have ever done anything on moles, but it doesn't matter if it is. The first thing to remember is that it is just a big number. It is 600,000 million, whatever it is. That is 6 times 10 to the 23. 6 times 10 to the 23 is pretty large number. It's actually 6.023 and then some other numbers times 10 to the 23. In other words, it's a very, very big number. But it is just a number. So what we have to do is to learn how to use that number. Now, in solids, we would normally, for a solid, weigh it out. We would normally put it on a top pan balance, find the mass. This is a balance. Just put the beaker in, put whatever we want into it, weigh it. And we can also find the mass of a liquid. That's very easy. And even a gas. For instance, if we weigh an empty balloon and then we blow it up and we weigh it again, it is heavier because it contains the gas. Solutions, the amount of chemical can be measured in various ways, but we normally have a volume and a concentration. A volume and a concentration. We measure out the volume in a measuring cylinder or a pipette. Conical flask or beaker are less accurate, but that's okay. And gases, we normally measure out the volume of a gas using something like a gas syringe. And for instance, in this one here, hydrochloric acid and magnesium, that's acid and metal, makes hydrogen. Now, these are my triangles. I have 3 triangles. They are relationship triangles like you have in physics very often. In physics, very often, we have things like voltage, current, resistance, V at the top, I and R underneath. I use the same thing. This is the one for masses. It may be useful for you to write it down. So mass goes at the top, grams. Moles is bottom left. And the molar mass, the RAM or the RMM or the MR, it doesn't matter what we call it, it's the molar mass, goes at the bottom on the right. To use this triangle, I just cover up what I want. So if I want the number of moles, I cover up the moles, and it's equal to grams over the molar mass. Fairly straightforward, simple. Now, I asked one of my students how he could remember this triangle. And you probably know what a mole rat is. A mole rat is a pretty ugly guy who lives under the ground. And so what this guy came up with, what my student came up with was this. He said, oh, I have moles and they are under the ground and they make holes by ramming. Moles ram underground. In other words, grams at the top, RAM or RMM, and moles down here. Now, if I want to find moles, all I have to do is to get rid of the moles. All I have to do is to say, moles equals what? Oh, yeah, moles equals grams over RAM, or grams equals moles times RAM, and so on. Okay. But he remembered moles ram under gram. It was underground. It was a simple way to remember the triangle. Okay. Solutions, we have concentration and volume. Concentration and volume. Now this time, moles is at the top. And I said, how do you remember moles is at the top? He said, if I pour the solution on the ground, then the moles have to come up to the top or they die, they drown. So moles is at the top, concentration and volume in cubic centimeters over 1,000. The volume has to be in cubic decimeters or liters. So if it's in cubic centimeters or mils, you have to divide by 1,000. So I normally put volume over 1,000 here. Okay, volume over 1,000 makes you remember which way round it is. Okay, so moles at the top, concentration, volume over 1,000. And the last one is gas. Their volumes are measured out. And for them, the volume is at the top, moles is at the bottom, and what we call the molar volume, 24,000 or 22,400, is at the bottom. This is like the one for the masses. If you remember the one at the masses, look at the one for the masses. Hang on. Here it is. For masses, we measure out the mass. Moles is at the bottom, and that's RAM. In this one, we have the volume at the top, moles at the bottom, and the amount for 1 mole, like the RAM or RMM. They will tell you whether they want you to use 24 or 22.4. That doesn't matter. Okay, so let's do a couple of questions using masses. Okay, so let's find out how many moles there are in these. I want you to have a go at this. So how many moles in this? Now, it's masses, and therefore the triangle we are using is grams at the top, moles down here, and RAM or RMM down here. Now we want the moles, so moles equals grams over the RMM or RAM. Okay, so 4 grams of NaOH, and it says Na weighs 23, O weighs 16, 1 hydrogen weighs 1. So have a go at that. Just have a go at that. See if you can do that. I think most of you can do that, no problem. I hope everybody is having a go at that. At least the first one, just one of them would be fine. How many moles in 4 grams of NaOH? Moles equals grams over RMM. So we have to work out the RMM of NaOH. That's 23 added to 16 added to 1, which makes 40. So the moles will be 4 over 40, and that is 0.1. Is that easy? Easy? Not so easy or difficult? Good. Okay. Okay, we'll move on. So I'll just go to the answers on these so you can see how you're getting on. So 4 grams of NaOH, 0.0055 grams of CaCO3, and a kilogram of water. A kilogram being 1,000 grams, you would have to turn it into grams first and then divide by the mass of 1 mole of water, which is 18. So we're going to move on in fairly soon. So I'm going to show you all the answers in just a minute. Show you all the answers in just a minute. We'll see who's got them all right. You get 1 point for each one of them. Come on, St. Mary's, you can do this. Don't just stare. Don't just look and go, yeah, I can do that. Have a go at it. You've got to have a go. Yes, you do. Well done, Silver Spring. Well done, Mathari Mixed. Well done, Wamawini. I'm sure that Dandora and Glory are having a go at it. Okay. Should we see the answers? Have you done it all, St. Mary's? Done it all? Okay. Good. Excellent. Let's see if you're right. Here we go. So here are the answers. Firstly, how you do it. Oh, sorry, St. Mary's. Let me just have a look. Hang on. Let me just have a look. Zero 0.1. Oh, very good. Well done, St. Mary's. That's very good. Well done. I'm very pleased for you. They are easy, but I want to make sure. So this is how you do it if you're not sure. So the moles in 4 grams of sodium hydroxide. I have to work out sodium hydroxide. So sodium hydroxide, that's 23 and 16 and 1. That's 40. The triangle says moles, is grams over RMM. That would equal 4 over 40. That's grams per mole. And that equals 0.1 moles. So that's how I do it. So I have to work out the RMM or MR first, and then use the triangle, this bit of the triangle, and that gives me my answer, and I would be happy. Okay, so here we go. The first one is 0.1. The second one is 5.6 times 10 to the minus 5, or 0.4 zeros, and then 5/6. And 1 kilogram of water, 1,000 over 18, is 55.56. 55.56. How many did you get? 3, 2, or 1? How many did you get? Show me fingers. 3, 2. Yes, I like it. So St. Mary's get 3. Wamawini are still doing number 3. Mathari, how many did you get? Well done, Wamawini. That's okay. 2 is good. Dandora, how many did you get? Very good. Okay, let's move on. I'm very impressed so far. That's very good. Okay, next. Hang on. Oops. Okay. The next one, using concentrations and volumes of solutions. So this is questions based on volumes and solutions. Now, if you're quite good at this, if you find this easy, just do B. If you find it more difficult, just do A, okay? A is more straightforward. B is more complicated. You have to do something else first. Just have a look at it, okay? If you find it difficult, do part A. If you find it easy, do part B. Don't forget that cubic centimeters need to be turned into cubic decimeters by dividing cubic centimeters by 1,000. Okay? So you have to remember that in this one, the triangle is moles at the top, concentration down here, and volume in cubic centimeters divided by 1,000. Okay, that's it. So moles equals concentration times volume over 1,000. I should think many of you have the answers by now. In the second one, you have to work out the amount of moles to start with using the first triangle, not the second one. Very good, Kabiro. Very good. Are we ready? Okay, for those people who found it difficult, here we go. So this is the first bit. So this is another example, a different example. How many moles in 250 cubic centimeters of a concentration of 2? Whoops. Well, what we would do is we have to remember that the moles is at the top, concentration is at the bottom, and volume over 1,000 is over here. So moles equals concentration times volume divided by 1,000. which in this case would be 2 times 250 over 1,000. In other words, 2 times 0.25, which is 0.5. That is how we do it, okay? Remember the triangle, and then remember this bit here, this bit here. That is very important, okay? So here are the answers. Here are the answers. Mute, please. Mute, please. Whoever it is. Thank you very much. Somebody is not muted, please. Could you mute? Thank you very much. Okay, so the first one for A, 250 of 0.5, concentration times volume over 1,000, 0.5 times 25 over 1,000 comes out as 0.0125. The second one is a bit more complicated. Because we need the moles, we have a mass of HCl, so we have to use the first triangle first to find the moles. That's grams over RMM. That's 3.65 over 36.5, which is 0.1. The volume is 250. Divide the 250 by 1,000. So we've got the concentration is 0.1 moles over 0.25, and that is 0.4. So who got those two right? Did you get 1 or 2? Did you get 1 or 2? Anybody? Did everybody get 1? 2, St. Mary's. What's your name, St. Mary's? You're very good. Well done, Silver Spring. That's good. As long as everybody's got 1, that's okay. As long as you can remember how to do it. Well done, Mathari. Well done, Mathari. But you have to be a bit careful, Mathari, if you come to the UK, because 2 fingers this way round is very rude. Brian, very, very good, Brian. You're top of the class. So Mathari, just be careful. Okay, let's move on. So the next one is the volumes of gases one. That's it's the triangle using gases. Now, a mole of any gas at room temperature and pressure, it's 24 cubic decimeters. If it's at STP, in other words, 0 degrees Celsius, which is a bit unusual in Kenya, unless you're at the top of Mount Kenya, is 22.4. But they will tell you in the question which one they want you to use. So here it is, the volume in cubic centimeters or cubic decimeters will be divided by 24,000 or 22,400 or 24 if it's in cubic decimeters. Here are 4 questions. Have a go at any one. They are getting more difficult. So if you are finding this difficult, have a go at number 1. If you think you're quite good, do number 2. Number 3C is more difficult, and the most difficult is part D. But have a go. Have a go at any one of them. Remember, moles is bottom left. Cubic centimeters is at the top. And 24,000 is at the bottom. So have a go. See if you can do these. We only have about another 15 minutes or so. So let's see if we can do these before we do some proper examination questions. You're working very well, students. Well done. I'm very impressed. Very good. Are you going to show me the answer then, Glory? Are you going to beat Brian at St. Mary's? A is 1 mole, you think? It's not 1 mole. You're close, but it's 24 cubic decimeters for 1 mole. So if there are 2.4, that will be 1 over 10 or 0.1. So the answer to part A is 0.1. Thank you for having a go, though, Kabiro. Well done. Zero 0.1, yes. How many old moles in that's yeah, that was 0.1. Yes, good. Up a bit. Show me higher up, please. Have you done part B? Well, no. A cubic meter will have how many cubic decimeters in it? How many cubic decimeters in a cubic meter? You need to work that out. A cubic meter will be 100 centimeters times 100 centimeters times 100 centimeters. So that will be 100 times 100 times 100, which is 1,000,000 cubic centimeters. How many cubic decimeters is 1,000,000 cubic centimeters? Well done. Well done, Mathari. Mixed. What's your name, please, Mathari? Student from Mathari. Phyllis. Phyllis, you are a star. See if you can do number 2. Number 2 means that you have to use the first triangle and then the third triangle. You can do this, Silver Spring. You can do this. Come on, Glory. Do you have an answer, Glory? Come on. Yes, that is the right answer, Glory. What's your name? Please. Well done, Roy. Roy is a French name for a king. So perhaps you're king of chemistry. Okay. We're a couple more minutes, another minute or so. Because I want us to look at a proper examination question. Just a minute. V 144. Six. No, not 6 times. Remember that hydrogen goes around in pairs. Very nearly, but remember hydrogen goes around as H2. So the RMM of hydrogen is 2, not 1. So it will be half of that. Okay, let's have a look at the answers. Let's have a look at some answers. Okay, here we are. Okay, the first one is quite easy. In the first one, we have 2.4, and if 1 mole is 24, then it's 2.4 divided by 24, which is 0.1. In the second one, 1 cubic meter, the best thing to do is to think, okay, how many cubic centimeters is that? That is 100 times 100 times 100, which is a million. And a million divided by 1,000 is 1,000 cubic decimeters. So that is 1,000 divided by 24, which is 41.67, which people like Roy got. 6 grams of hydrogen is 6 divided by 2, because the RMM of hydrogen goes around in pairs. So each hydrogen weighs 1, but a hydrogen molecule, H2, weighs 2. So it's 6 divided by 2, which is 3 moles. 3 times 24 is 72. The last one is the most difficult. It says if we start with 1.2 cubic decimeters, well, we can work out the number of moles. That's 0.05. And it tells you that that has a mass of 2.2. Well, I know the moles and I know the mass. So that's the first triangle again. The RMM is grams over moles. 2.2 divided by 0.05 is 44. Now, the most common gas with a mass of 44 is carbon dioxide. Here's a proper examination question. It uses just moles. You can do it. Let's have a look at it. This is the last thing we will do today. So if a student starts with 0.1 grams of magnesium and adds it to 50 cubic centimeters of 1 mole per cubic decimeter H2SO4, calculate. 1. Firstly, which is in excess, Mg or H2SO4? How many moles of H2 should be produced, and what volume will that take up? So there's the question. 0.1 grams of Mg and add it to 50 of 1 mole per cubic decimeter H2SO4. Which is in excess? How many moles of hydrogen? What volume will that be? Okay, so that's the question. And I'll show you roughly how to do it first. As soon as you've written down the question, okay. I'll come back to the question in a moment, in case you haven't quite written it down. I will come back to it in a moment. So here is the equation which you need. Okay, that's the equation you need. Okay, there it is. That is the equation. H2SO4 plus Mg goes to MgSO4 and H2. Here's the question, the whole question. So see what you can do. I'll give you about 5 minutes and see how you are getting on. So the equation, Mg plus H2SO4, 1:1, goes to MgSO4 plus H2. See if you can do it. So the first thing to do is to work out the moles of Mg and then the moles of H2SO4 and see which number is bigger. Moles of Mg moles of H2SO4. Come on, Roy, concentrate. We only have about 5 minutes, guys. I will go through it all in a minute. For those of you who are finding it difficult, let me start. So this is the first part of the question. Well, for magnesium, it is grams over RAM, which is 0.1 over 24, which is 0.00416. 0.00416. That's the moles of Mg. The moles of H2SO4, well, it's got 50 of 1 mole per cubic decimeter. Remember, from that triangle, moles is concentration times volume over 1,000. So it's concentration times the 50 over 1,000. That's 0.05. So the H2SO4, there is more of the H2SO4. Look at that again. Very simple. 0.1 grams of Mg. That's the first triangle. Moles equals grams over RAM. So that's 0.1 over 24, which is the RAM of NaOH, of Mg. And that's 0.1 over 24, 0.00416. Sulfuric acid, that is a solution. So moles equals concentration times volume over 1,000. Concentration is 1. Volume is 50. So 50 over 1,000, that's 0.05. Look at the two numbers. There is more H2SO4. If there is more H2SO4, that means there will be some acid unreacted. So the moles of hydrogen, well, if you look at the equation, 1 Mg makes 1 hydrogen. And so if there was less magnesium than sulfuric, then 0.00416 of Mg will make 0.00416 of hydrogen. Okay, so it will make 0.00416 moles of hydrogen. We don't use the moles of the sulfuric acid because it is in excess. In other words, there is too much of it. Some of it will be left over afterwards. What is the volume? Well, simply for any gas, the volume equals the moles times 24,000. So it's 0.00416 times 24,000, which is 100 cubic centimeters. And that's the answer. Okay, I'm going to stop sharing for a minute. Okay, I'm going to stop sharing for a minute. Did anybody get that? Did anybody manage to get those answers? That 100 cubic centimeters of hydrogen. Anybody get that? Anybody get that? Did any? Well, you got the first bit. That's good. That's good. So, who got the magnesium moles? That it's 0.1/24. Did you get that? That the magnesium is 0.1/24. Yes, good. If you got the concentration one, the sulfuric acid, that was the concentration times the volume over 1,000. You can look back on this afterwards because it has been recorded, and I will send the PowerPoint to your teachers so that they can look at it again. But for now, what I'm going to do is I'm going to show you what's happening tomorrow, because none of the teachers can be here tomorrow, but I have sent something to the supervisors so that they can show something to you. And what it has, I hope I can find it. Hang on. Okay. Tomorrow, what I hope your teachers, come on, why is it not showing it? Oh, come on. For some reason, it is not wanting to share what I want it to share. That is very peculiar. I do not understand why that is happening. Okay, it doesn't matter. Tomorrow, you will get a copy of another PowerPoint which has more examples about moles. And what I would like you to do, it has the moles questions and the answers. It shouldn't take you too long, but try to remember the triangles. Okay, so we're going to finish by going back to the triangles just to remind you so that you can remember how it all goes. Oh, this is it. Sorry. Here we are. So this is what you will see tomorrow. It reminds you of the triangles, the three triangles. It then has some questions, some of which are the same as today and some of which are different. It's worth having a go. Then it's got the answers, and then it's got one on concentrations and volumes, and then it has one on volumes of gases. And so it's a lot of questions so you can see them. And then it's got some proper examination style questions if you want to try that. Okay. So that is where we're going to stop for today. I'm going to stop recording.